Okay, I'm assuming that again everyone solved the exercise and we are comfortable with template classes. Let's begin with our main function. Okay, like we said here, in our binary search tree, our node now contains data, and it contains a pointer to a node, and this is one node, named left, and a pointer to a node named right. Okay, one as always. And since this is a template, we want it to have anything. And I'm the template class T struct node. Okay, and then we're gonna have T data. While indeed this is an integer binary search tree, we want this to be of characters of anything. We make it generic with the templates. And then we're gonna have pointer to a node named left, pointer to a node named right. And of course, as always, I forget everything. I'm pretty sure I forgot the syntax for struct, but let's build and make sure that I did that right. Oh, you want that happens. Interesting. I didn't know that. Yeah. Okay. Let's begin writing our class for our binary search tree. We're going to do class binary search tree, and we're going to have our private and our public. Okay. Type. Okay. Remember in our linked list, we had a pointer to our like head. Actually, we needed to know where to start, right? In a binary tree, we also need the same thing. We need some way to know, يعني مثلا if I'm finding or if I'm inserting or if I'm doing any of this, how I need to start. Remember when we always لما عملنا delete, when we did our find, we always started at the root. That I need the root. I need some pointer that points to my root. Okay, well I'll call that root. What type is root of? It points to a node. Okay, I need node, oops, just like our linked list, node star root. Okay. I need my constructor. Now we need a constructor, BST. Okay. Again, in the main function, when I make my binary search tree, do I need to give it anything? Do I need to give it a size or anything like that? No parameters I don't think we need, but we don't need parameters. Kalida, in our constructor, we need to initialize all of our private attributes. Can we give root an initial value? When I first create, this is like this tree has values in it. So when I first come to create a tree, my root, the tree is empty, so root points to null. So there's nothing. The initial value that root can take is null. Okay. I'll just like to have this here. Okay. Now let's start with inserting. Eventually I want to do something like my binary search tree dot insert. Oh, oops, big mistake. This also should be a template class. Actually, we want to make it generic to be of anything. But let's say I want to have my binary search tree. Actually, we want to build that same binary search tree that is, oops, this binary search tree. If it's of integers, my binary search tree, and I want to insert مثلا in the beginning I want to insert 15. I need an insert function, right? فطبعا I'm gonna go over here and I'll do void insert t data, and I need to build my insert function. Like we explained in the inserting algorithm, you start at the root, and if it's less, مثلا if I want to insert, احنا قلنا هنا 15, but like let's pretend I wanted to insert like 10 or something. I start at the root. If it's less, I go here. 9 is 10 greater than 9? It is. I go here, and everything gets inserted as leaf. Remember, is 10 less than 11? It is, so 10 would go here. If I remember that, we need to do this algorithm, and this needs to be done recursively. Okay, I'm not going to do this in this function. Like, this will become more apparent after we're done. Like, it's kind of difficult to explain why we're not going to be doing this here. The way that we're going to do it is we're going to have a private function, actually, هنا اسمها, that's going to do the actual inserting, and then this public function is going to call my private function. Why? Why do we do that? I'll explain it. It'll only make sense when you see it. Okay? But let's begin. Actually, I can do better than that. Okay. The reason it's going to be a private function and not a public function is because this function will be recursive. Okay, like remember when we were explaining, we thought of it recursively. That syntactically, for a function to be recursive, it has to have a certain function definition so that it can be recalled. And for the insert function, it needs to have the root at all times. Basically, my private function is going to take this form, and it's going to have to be a Boolean function also. Why? برضو hopefully explain I argue that my insertion function is going to be node. It's going to take a pointer to a node, and it's going to take basically like a node like here. And like, and we'll name that مثلا, let's name it a root node. Actually, it's going to be like any node, unless it's a leaf node, is going to be a root node. Okay, that's just the name we're going to give it. And then it's going to take the data that you want to insert. We need, like, here, we need this to be a Boolean function because of the nature of recursion. This will obviously hopefully make more sense when we like go into the function call. And it needs to have, برضو it needs to, at all times, it needs to have like reference to the root node. So we can't have this out here in the main function عشان how are like, sorry, this can't be public. Imagine here لو شلنا, like, we took it from underneath the private here to the public. How are you gonna like call it? What are you gonna give it for this node pointer? You would have to expose your root, which you don't want to do because it's not like the whole point of classes is you don't want to expose these things to your user. But that's why we're gonna have it as a private function. Like, we're having it as a private function so we can basically like exploit like the benefit of recursion and at the same time maintain the benefit of classes, which is not exposing my sensitive private variables out here to the main function. Okay, سيبكم من bool دلوقتي, like don't mind this bool right now. I'll explain why it's needed برضو for recursion. And if I rewatch this and feel like the recursion part wasn't well explained, I'll hopefully like, if you guys need it, if you need like another like separate recursion explanation, then I will definitely be sure to be posting that. Okay. Remember our linked lists. When I come to insert, just like my linked list, I could be inserting for the first time, or I could not be inserting for the first time. So remember when I was inserting into my linked list, I asked myself, I would be like, is my linked list empty? So, and how do I know if my linked list was empty? If my head pointer was null, how do I know that my tree is empty? If my root is null. Okay? So as always, we're going to start like that. I'm going to say if my root, wait, let me make sure, if my, okay, sorry, let's backtrack a little bit, okay? Let's fill in our public function first, sorry. Let's fill in our public function first. Okay? We're going to call our private function insert. It needs some root, and it needs the data you want to put. فهنا from main, I want to put 15. But like obviously I can't call this private function because A, it's not visible to me, and B, I don't have a root to give it. Okay? That 15 gets passed to this function. Okay? هنا through data. And this function can call this function because 1, it can see it, عشان it's within the class, and 2, because it has a root to give it. So I'm going to give it root, اللي هو the root, not a root, like the actual root of my tree, which is my private variable here, and I'm going to give it the data that was passed that wants to be added, for 15 دي. Okay? Okay, so now we're ready to understand the very first call. The 15 is coming here. It's going to be passed to this public insert function with data, and then it's going to be given the actual root, which according to the constructor هنا at this point, the constructor constructs it, and root is null. فهنا 15 is going in with root, which is null, and 15. Okay, so now we're actually ready for this insert function. Okay, now inside a root, because of this function, يعني inside here, root is passed to me, the actual root. صح? So I can say, عايزة أتأكد first if my tree is empty, like we did over here. If my tree is empty, I'm gonna go if a root equals null. Okay. Before I do this, معلش, I want to add a constructor to node, just to make it easier, because like instead of being like new node, and then being like node at left equals null, right? If I just want to do a constructor, okay? For node, it's gonna take t, we'll call it d, node star l, node star r, and then data, which is this thing, equals the data that the user wants, left equals l, and right equals r. Okay, just want to make sure that I didn't ruin anything. There's no errors. Node star root. One second, what have I done? 1 second. Silly me, silly me. This is a generic, a node of t root, node t root, because like again, يعني a node, we made our node in such a way that it can be an integer, a character, if we need to specify that. Okay. Yeah, it just wants me to return something, return false. Okay, good, I was just making sure that the syntax is still correct. Okay, فإف احنا زي ما قلنا a root equal null. Okay, what do I do? هنا, let's go back to the drawing. I need to insert for the very first time, صح? Root here is under the name a root. Okay, but this is actually root because it was passed in from my insert function. So I'm going to say a root equals new node. وبعدين, thank God I gave it a constructor, so now I can actually say my constructor takes the data, which is passed in to me from here, data, and it takes a left pointer and a right pointer. فاحنا قلنا we want to insert 15. Okay, 15 is a node, it's not just data. It has a left pointer and a right pointer, and then since it's a leaf, remember لما قلنا في الأول, we always insert as leaf, and a leaf, like we did with our definition, is a node that has no children, meaning its left and right nodes are null. صح? The node that I'm inserting here, which in code is this line, new node, has data, which is the main function gave us 15, and it wants, according to the constructor here in the struct, it wants the left and the right. Left is null and right is null. Okay, for now my root is 15. It's no longer null. By this statement in code, that's what I've done. Oops. Let's do something better. Oh my god. For now my root is no longer null, it's in fact 15. That's my root. So now we have dealt with the case of إن I'm inserting for the very very first time. Okay? زي ما عملنا في linked list. What's next? طبعا since this is a non-void function, if I run this هيطلع لي error. I need to return something. And برضو guys, I've noticed when I was looking at your code, you have to return like at every scope. فمثلا if I have an if, I have to return inside the if and inside the else. If I have if else, everywhere there needs to be a return. Inside my if I have to return something. وبعدين خلينا let's think about like the return type as a successful, like it returns true if it's successfully inserted, and it returns false لو if that node exists. Okay, so I'm gonna return true because it's successfully inserted. And now I need to think about my else. Okay. If I'm not inserting for the first time, مثلا خلينا let's go down here and do my binary search tree dot insert 16. What's gonna happen at this function call? Actually, let's look over here. If I want to insert 16, احنا قلنا every node has to be inserted as a leaf node. فخلينا let's remove this. For code it's not conceptually needed. If I want to insert 16, every node is inserted as leaf node, and I start at my root and I ask is 16 less or greater? Greater, less. Okay, it's greater. Where do I go? I go here. يعني there's nothing here, so I go here. Okay, وبيجي معايا my pointers برضه. Null, null, null. So let's mimic this in code. Okay. else, but first let's do a case in what if it exists. فمثلا if a root at data equals data. معنى كده إن هو if I do my binary search tree dot insert عملت 15 again, that shouldn't be able to happen. Like I want my function to return false and say no, we can't do that. Okay? If I remember, I'm like passing in the root itself عشان when we insert we always start at the root, صح? I'm saying if my root's data is equal to data, and if it exists, then we return false. Okay, actually that's not entirely correct. The reason that's not entirely correct is because a root, you'll see it's not always going to be root. When I call the function recursively, a root will not be root. It will make sense, inshallah, I promise, hopefully, when we take like examples, as we add more and more nodes, you'll see. Okay? But for now, يعني, this 15, برضو it's going to be called with root. هيجي هنا a root will, يعني root is, هيبقى a root, like what's passed in here, this function is called with root, صح? And 15. بس المرة دي we have 15 in here. And by the way, we didn't add the 16 yet. We have this 15 برضو it's passed in. فطبعا it's not going to go into this if statement, it's going to go into here. فهيسأل if root's data is equal to data. Root's data, remember root is a pointer to a node that has a data field which is 15 عشان 15 is our root, is equal to data اللي هي احنا بنحاول نزودها التاني, then don't let this work, return false. Okay? بس. Now بقى هنا else we are not inserting for the first time and we're inserting something legit. Okay? Meaning مش duplicate. Exactly like احنا كده خلاص we're doing our case بتاعت 16. Let me remove this statement, we don't need it. Okay, like the process that we just drew now for 16, let's deal with that. So we have two cases when we come to insert, when it's not the first time, when it is not the first time. either the data that I'm trying to insert is greater or less than my root node, okay? And we dealt with the fact if it's equal, it just shouldn't work, صح? If my data is less, then I must insert to the left, see? If it is, let's use the nicer drawing. Okay, removed less and greater. If it's less, I have to insert to the left, and if it's greater, I have to insert to the right, okay? If, else if, okay, my data is less than a root at data, insert to the left, okay? Remember up here, when we said, remember recursively, let's say I want to insert, and Hashil, I'm going to remove this 16 from here, okay? But then I want to insert it. So remember, everything is inserted is leaf. If I ask myself to the left is less, وهنا is greater. 16 is greater than 15. صح? So I look at the right subtree. صح? And then 15 is less than 24, so I look at the left subtree. Do you see how when I said is 16 greater than 15, I looked at this subtree, فكده it's as if I'm zooming in here, and now 24 is my root. Does that make sense? It's a whole new problem again. I'm repeating the same problem, but instead of 15 having been my root, start at the root, 24 is my root. I'm making the same problem في نفسها. That's as if I'm calling this insert function, and instead of starting at root, which is 15, I'm starting at the new root of my new tree, which is 24. Do you see that? That's recursion. فإن code, what am I doing? I'm inserting. I'm inserting. صح؟ زي ما this public insert function called insert and it gave it root اللي هو 15. لا أنا المرة دي I want to give it this 24. And who is 24? It is the right child of the actual root. Okay? This is less than. I just described the case of greater than. Let's do greater. If data is greater than a root, then I want to go to the right. This function, again, I'm calling the insert underscore function, which is this function, and it needs to take a pointer to a node and the data. From the pointer to a node, which is root. Already it's 24. So where is 24? احنا قلنا it's the right. Remember, the node at the end of the day is a pointer that has a right and a left. مش كده? So we need to give this, my insert function, the right child of root. So where is that? A root at right. Remember? Node ahead. Pointer to node left and right. And then the data. هي نفس الداتا اللي هي 16 اللي أنا عايزة أدخلها. That I want to insert. Okay? And we need to return something, as always. I'm going to return whatever value this insert call returns to me. Okay? We're going to trace this. In recursion, it's always helpful, maybe go over some tips about how I recommend dealing and thinking about recursion. Okay? طيب, else, we dealt with greater if the data is less than the root's data. مثلا, I want to insert let's look over here. I want to insert بدل 16D. Let's say I want to insert like 3 or something. Okay, 3. Always start at the root. Always start at the actual root D. Who does that for us? It's the public insert function. Okay, it will get past the actual root. Okay. So we're starting at the root and I want to insert 3. Is 3 less than 15? It is. So who is my new root? It is the left child of me, which happens to be the root. ومي معناها who am I? I'm a root. Okay? Yeah, hopefully that makes sense. Okay. We really don't need the braces, do we? Okay, for return, I'm gonna call my insert function with my left child and data. So now when this is called, like my left child is considered the root of an entire new tree and everyone else is gone. وأنا بحاول أدخل 3 like over here, I look to the left here and I consider the question gets resolved with this tree and all of these people are gone for now. Okay? And I repeat the process all over again. Why does this work? Okay? First, let's run the code, make sure it works, وبعدين we'll trace it. Okay, so this is a template by node t. I didn't even listen to my own thing. See, you have to always return something. Okay? We're just gonna remove this if. عشان if it's greater, insert to the right. If it's not equal, and if it's not equal, else is it greater? No, else it has to be, it's gonna have to be less. Else, if it is not equal, اللي هو the data that I'm trying to add, it's not equal and not greater, it must be less. Thus, it must be inserted into the left subtree. Okay. Let's trace this. Okay. مثلا خلينا let's try to build this tree. Insert 9. بعدين my binary search tree dot insert 5. Okay. Let's trace this. Okay. The first time I insert 15. خلينا, I'm gonna remove all of these comments. أول مرة insert 15, this function is gonna be called with 15. صح؟ And then inside insert, we're gonna call insert, small insert with root, اللي هو the actual root, which at this point, عشان أنا when I first created my BST, دخلت constructor and root is null. صح? By the time I get to this line, which is the line we are tracing right now, my root is null. Root which is equal to null, and my data which is 15. That's what's happening. فيلا نطلع الفانكشن. And this function is the insert function. المرة دي داخل لها ايه؟ Root is going into it with a value of null and data which is 15. فهنخش في if statement. So a root this time, like the name a root, inside it the value contains the actual root, which at the end of the day a root contains null. Is it null? Yes, because this is the first time I'm inserting and my binary search tree is empty. Okay, طب what do I do? Okay, a root ده, let me go down here to the data. Let's draw it برضو. It says a root ده هياخد a new node that contains data which is 15, whose left pointer is null and whose right pointer is null, because we always insert as a leaf, and a leaf is a node that has no children. And then we're returning true. فخلاص, we leave this function, we return back here. This worked, everything's fine. خلاص, all the calls are removed from the stack. All these calls are done. Okay? The second time we insert, خلاص, our tree, this is our tree, it contains something. I want to insert 9. Okay? This is the public insert. I'm going in here. I'm going into my public insert function with data which is 9. I'm calling with root. Who is my root? My root is no longer null. My root is the root which contains data 15. And my data, the new data I'm trying to add, is 9. فهنطلع للfunction. We're calling it this time with root, which has مش equal to 15 طبعا, but its data is 15. And my data that I want to add is 9. Okay? فa root اسمه contains data 15, so it's not null, so I'm not going in here. Else, if my data is equal to data, so is root up, this is better. This makes more sense. Okay. Is 15 equal to 9? It's not. I'm not trying to add the same thing. Is 15 is 9, is data greater than 15? It's not. فهعمل ايه? I'm going to insert this 9 to the left, and we said anything to the left is less, for this works. For this is the function that gets called, and what does it get called with? This is really important, okay? Remember, a root, it's data. خلينا برضو that's يعني a root اللي هو داخل له root, like at this point يعني a root can داخل له root, root's data is 15, but a root actually has يعني like it's all the same at the end of the day. Let's just say a root. A root's data is 15, وطبعا because the tree is empty, its left is null, left equals null, right equals null. صح? Because it's the first element. Okay? So I'm inserting now with a root's left, which is null. So this function gets called again before it gets called again. Okay, with null and 9, which is the data I'm trying to add. It gets called again. A new call happens over here. With null, a root with a root equals null. Its data is null, its left is null, and its right is null, and the data which is 9 that was passed with me. Is a root null? This time it is null. Okay, we're considering a root, like this is the brand new root. Okay, since it's null, create a new node that has this data. So we're basically saying do this. صح? And 9 and return true. Okay, فهنا I return true, and the value that is inside like a root dot left, which is this new node that contains data 9, for that worked. وطبعا there's a mistake here. This has to be passed by reference so that we can be able to change its value. Okay? For that worked. We have returned true, فخلاص this call is done. And we have like this old call هنا from when we inserted 15, and that's gonna return true. And we're back here, and this returns true. And in fact, this call of 9 has worked. وبعدين when we do 5, it's gonna be the same logic. Let's also actually like trace it برضو so that we can really understand recursion. Okay? But when I do this برضو, insert 5, I go to my public insert function, I do 5, I give it the actual root, which is 15. فهنا داخلي 15 and 5, the new data I want to add. I go up to this function, and for the first time I call it, I have 15 and 5 and 5. Is ال 15 اللي داخله لي دي اللي هي داخله في a root, is this null? It's not null, but that's not gonna work. Is it equal? Are they equal? They're not. Is the data greater than 15? No. 5 is less, so it's gonna go left. But we're here again. Okay, so this time this function is gonna be called with 15's left. And is 15's left empty? It's not, it's 9. So this function is gonna be called with the node that has data 9 and the 5 that I want to add. Okay? But let's go, it's the same function. فيلا نخش تاني. Okay, 9 and 5. Is 9, again, a root is 9 and data is 5. صح? يعني the comment on the left is the value of a root, and the comment on the right is the value of data. Is 9 null? It is not. Is 9 equal to 5? It is not. Is 5 greater than 9? It's not. Is 5 less than 9? Else we have no other option. خش هنا. Okay? We need to go with the left of 9. And who is to the left of 9 here? Null. Nothing. صح? But this function gets called now with null and 5. Okay? Going in again. This time with null and 5 برضو. Okay? So we reach our recursive base case. Is a root, oh, this is the value of a root, is it null? It is null. So what do? I need to give it a value. I'm going to create a node with this call and put data in that node, which is 5. So I'm going to do 5 here. And then I'm going to return true. فخلاص, this call gets like pushed off of the stack and it returned هنا, this returned true. Okay, for now we're in this call. That call also will recurse. هيرجع لها, like the return values can get passed to that call, which is true, true, true. It's gonna give this true and it's gonna give this true. And then this function will finally, the whole insert function, خلاص, after all those calls are like pushed off the stack, we go back here, that gives us true, and this is a void function, so we just like throw away the return, and that's it. It worked. So how do I verify that this is working? Let's create a nice little simple like a couting displaying function. فأقول مثلا t عايزة أجيب like the data at whatever node I give it, return node بس كده عادي. فهنا I just want to return the node. فمثلا let's return الroot. Okay. فخليني see out here. First I want to see out here. See out as soon as I create it. Return, my binary tree, so my binary search tree, dot return node. This is when I create the node, that this should be null. Like something wrong should happen here. Return root at data. بس عايزين الداتا يعني. This should be null. I should get like 0 or something. Okay, that should work عشان يعني like you can't like see out null. Hopefully that's the reason. Okay? But when we insert 15 at this point يعني مش بنبص هنا, at this point 15 will become the root عشان it's the only element there. فالمفروض 15 should come out. Good. Okay? And in fact at all points 15 is gonna come out عشان we're just see outing the root. صح? So let's change this function. At this point لما 9 تخش, like طبعا at this point احنا ما شفناش ال 5, 9 is inserted to the left of 15. So let's try to get that for root at left at data. I should see 9. This call should give me 9. Like we're just validating and making sure that this is working. Good. Let's make it. I عايز أشوف ال 5. Okay. So I want to move this call down here. Okay. And I want to see that 5. But at left, صح? Root, left, data. Should see 5 if I did my code properly. صح? Let's insert something هنا مثلا so that we can, something that would go to the right of 15. Let's insert 24. My binary search is insert 24. And I want to see the right. أخلي function دي تديني the right. This is just like a function. يعني like just an أي كلام function so that I can like test my work. بس طبعا we have to do a find function. يعني. Good, 24. So the node that exists to the right of root is 24. Like this helps me understand and know that hopefully I did my inserting function correctly.